Okay, we're about to cut the contours and the chamfers, but I want to make an edit to how we're going to cut them so that we have the best chance of dealing with this scenario right here, the reality of imperfect stock. It's kind of the definition of stock. It's imperfect, and then we're going to cut it into a more perfect shape at the mill. And by imperfect, I mean that this stock has a significant lean to the right. It came from our tiny little horizontal bandsaw that just isn't great at cutting perfect cuts. What you can do is start noticing the imperfections and then making a decision about how to deal with them. Ask yourself, can I locate the two faces that were cut by the bandsaw? Those are usually the worst, and so put one of those down against your parallel. And then think about the following decision. Do I want this bandsaw edge to be sitting on both parallels, or do I want these nice, clean, extruded faces from the factory to be sitting against both jaws of the vise? It might feel more secure to put your stock down on both parallels. Isn't that what they're there for, to support your stock? But look at this little shadow right here. That shadow suggests that one of the best faces that I've got is leaning away from the jaw of my vise, off axis. Notice how if I rock the stock up against the jaw of the vise, I can close up that shadow, presenting a good factory face to the jaw of the vise. And yes, it does lift up one corner of my stock off the parallel, but that's not as big a problem as it might seem, because as I close the jaw of the vise and clamp down now on two nice factory faces, my stock stays put. It doesn't need that parallel underneath it. It doesn't need it so much that I can even take it out and proceed. With the right amount of clamping force, my material will stay put, even when the force of the cutting tool shows up. Good, now that we've clamped our material in a better way, let's probe our work coordinate system in a better way. And we've set it up in Fusion to be top center. So, park the probe in the center of your material about 1/8 of an inch above. Then come to the probing screen and arrow down to web x-axis. A web is something positive protruding, where we want to touch both sides of it to get the center. Then go ahead and enter your work coordinate system, 154 point, and then your individual number. Go ahead and set probe Z to no. You can go ahead and probe your Z coordinate later using single surface. We've already talked about how to do that. And then set your X dimension. This is the dimension of your stock, 1 point. And it's critical that you put the decimal point in there. And then this line, Z, with a negative 0.5, means that I want the probe to go out over the edge of my material and descend 1/2 inch before coming back in towards the material, searching for it. Let's watch it happen by pushing cycle start. The probe goes out, down 1/2 inch, and then searches for material. Then it comes back to the center, goes out in the other direction, down 1/2 inch, and then searches in the other direction for material. Having touched both sides of the web of material, it calculates the middle. For Y, the procedure is the same. Just come down to web Y-axis, enter your work coordinate offset, no to probe on Z, set your stock dimension to 1.0 inches, and then set a descent height. Negative 1/2 inch is plenty. Then hit cycle start to probe your Y-axis coordinate. The probe will touch the front and the back, and then return to the middle and calculate the middle based on those two touch points. That's it for newness. Just remember to probe the Z with single surface, and you'll have your X, your Y, and your Z at the top center of your stock. And if you're wondering why bother with this new technique, just imagine the errors that are there in every piece of stock. Imagine how centering your model in the stock will let some of the errors be on the left, some on the right, some on the front, and some on the back, but we will be further from all of them when we center our model in the stock.